Okay, so welcome back to the second video of the series, and on this one we're going to start with real FM. So on the previous one we learned how to use an operator and all the features we get inside. So now we're going to start using the other operators and using real FM synthesis. So okay, so now we know that we with one operator we can get a sound. So I'm going to go and of course load the default patch, and we get just a nice sine wave. All right, just super simple. Now I'm going to go to this one. And if I go to this one, we know we have the same exact thing for now. So if I turn the volume up on this one, we get a crazy sound. And, okay, so that's cool. All right, okay, but, how do we get this sound? It's going from mild to wild. Okay, so I'm going to go right now and I'm going to turn off this one and I'm going to see what's going on this one, that it's just making, the synth get this, crazy sound. I'm going to turn off the volume, and if I play a key, notice nothing happens. We get no volume at all. And again, what the F is going on? So this is how FM synthesis works. So welcome to FM synthesis. So yeah, okay, so the number 2, in this case, the operator number 2, what it's doing is providing an instruction instead of providing a sound. So where can we check all of this? So right here on this chart, you get, kind of a very visual way of knowing where the operators are. And notice that the one, and I'm going to go and turn on the volume on the one. Notice that the one is pretty close to the out. So this means that the operator number 1 is like the one that is going to be outputting the sound. And notice that this one, the one that we have right here, is the number 3. So if I go to operator number 3 and turn the volume up, we can see that 1 and 3 are the ones going out. And this is how it works. The operators that are just directly going to the out are the ones that will output the sound. And the other ones are just going to be modulating whatever they are connecting. So the 2 is connected to the 1, so the 2 will modulate the 1, and everything else is modulating the number 3. So think of this like a pack leader. Let's say that the 1 and the 3 are just the pack leaders, and they are the one that, the ones that will speak to the tribe, let's say, and all the other ones are just collaborators. Their voice will not be heard directly, only when they go through the pack leaders, right? I know it's just the dumbest example, but at the end of the day, this is how it works. The 1 and the 3 are the ones going directly out, and the other ones are just, kind of advising the 1 and the 3 in how they should sound. That's why if I turn the 2 and just use the 1 and the 3, we get the same sine wave. The only thing is that we just get it louder, because on the 3 and the 1, we are doing the same sound. But as soon as I go up on the operator number 2, this one is modulating the operator number 1. And notice that the 4 is going to do the same through the 3. So we're going to start getting different sounds. But remember, these ones are a little bit different from the ones going out. Okay, so let me just give you a different example. And just to, so you can understand how this works behind the scenes, because this is important to know how it works. So now I'm going to go to the 1 and the 2, all right? They're just the same thing. They're doing the same thing. And of course, we get a different sound. So at the end of the day, what it is just an operator outputting an oscillation. And if you think about this, what an oscillator is, it's something that, will output a sound, but at the end of the day, it's just a waveform. So it's an oscillation or a waveform that can be used as an LFO, right? So that's why we use LFOs. It's just a waveform giving an instruction of how something should behave. And this is what the operator 2 is doing to the operator number 1, is providing an instruction in how, it can be, modulated in this case. So for now, we just get that sound. But what happens if I go to the operator number 2 and I try to use it as an LFO, right? We know how an LFO works. So we can actually do this. If I go to the fixed one right here and I go all the way down, just going to scroll all the way down and I, press a key, notice right here on the side, we get the same sine wave. It's a bit more complex, of course, but we can see that it's moving. And it's because this one, since it's super low, and now we know what the fixed does, of course, we talked about this on the previous video, we know that this one is going super slow and it's modulating the pitch of the operator number 2. So we are using it as an LFO. to modulate the pitch. And as soon as I go up, we can really hear that modulation because we are going faster. So we can hear modulating the pitch. Right? So we are using this as an LFO. There's no difference at all. Now, of course, what happens if we go fast on a LFO? Right now, we can hear that movement, that modulation, because it's super slow. But as we go fast, when it starts going really fast, we lose perception of the movement, and we start hearing a pitch. And this is how we perceive sound. When it goes super fast, we just don't get a sense of, something moving. It's just super fast, and we just, hear a pitch. And this is what's happening on the operator number 2. We are getting a pitch. So instead of maybe using a fixed one, we are using ratios because we know that this is, playing a key, and we are hearing the sound that's going on a certain, part on the spectrum. So we hear, of course, a C note or a D note or whatever note. And of course, if we go up, it's going to go faster and we hear something. But not when it goes really slow because we are entering into the LFO. So at the end of the day, the operator number 2, what it's doing is just doing kind of a super fast LFO if you're using a normal ratio with a sine wave. And in this case, if you change the wave, of course, this will modulate whatever, it's going to modulate differently the operator number 1 because this one is just, again, advising the operator number 1. And the sound will change just like it would sound with a normal LFO, right? So that's, the theory behind the scenes of how this works. Okay, so let's talk about a little bit more about some technical aspect of, the words that we are using. Right now, we know that all of them are operators. And I'm going to go back to the default template. We know all of them are operators. We know that. Now, of course, we know now there's a difference between the operators that are going directly out and the other ones that are, modulating whatever they are modulating in this case. So there is a clear difference. So of course, we need to use a different name for them. They're all operators, but the ones that are directly going out, in this case, the 1 and the 3, they receive a different name. And the name, it's carriers. They are going to be the carriers. And the other ones, the ones that are not going out, are going to be demodulators. So now we know 3 different words. They're all operators. The ones that go out are carriers, and the ones that are doing the actual modulation they are modulators, right? And this names is something that we really need to use on a Femme Synthesis because that's the difference between them. How are we going to know which one is directly out and which one is doing the modulation? So we use a very specific keywords. Now notice again that we have a number 1 right here. And this is the instruction. The 1 and the 3 are the modulators, the carriers, and everything else is they are modulators. But this, is something that we can change because we have different ways of connecting the different, the different operators. And now maybe the 1 is going to do the out and then the 4 is going to do the out. And I'm going to go and do all of them at the same time so we can see them all. So, now the 1 and the 4 are going out and not the 3 anymore. Now the 3 is modulating the number 2 and the 2 is modulating the number 1. So we have different ways of just, doing pretty much the same. But the sound will change radically when we change this. And notice we get a lot and they all do different things. So now 2 operators are not going out anymore. Now we have 3 instead of 2. And then if we keep going forward, we get different variations of how we can, go out and which one is going to modulate which. And again, we just get different ways of doing this. And by default, you get 32 ways. And these are called algorithms. That's the technical name for this, algorithms. And notice that 32, which is the last one, it means that all of the operators are going to go out. So if I go right here and select different waveforms, it's like getting creating a synthesizer with 6 different oscillators, pretty much. Yeah, it's like connecting 6 different synthesizers, and they're all going out. No one is modulating, the other operator. So again, you get 32 ways of combining the different blocks, and this is great because maybe let's say that you're just kind of randomly making a sound on the operator 1 and the 3 and this 5, right? And then maybe you want to see how it will sound when you do different combinations. So you're just going to go and just start playing with the algorithms and check if you get a different sound or you get a better sound. Or maybe you want to connect a different block to something else and do something else really crazy. And notice we get, again, different variations of this one. This one is doing the 6, and at the same time it goes to the 3, but then the 4 is doing the 3 as well. So again, we get weird combinations, and they're all, very special. So again, by default, we get 32. And if you want to go from the 1, you go back to the 32. And this is using this one, and this is why you can go back as well. The 32 is cool when you're just building blocks, because sometimes maybe you want to hear what you're doing maybe to the operator number 2, that at the end of the day is going to be modulating the number 1. So it's, nice that you go to the number 2 and just audition whatever is that you're doing on the number 2, right? Maybe you're not going to use this one, but then you can hear what you're doing, and then you can go back and see how, and just check which sound you're going to get when modulating the number 1. Okay, so let me just show you something else. It's going to be a little bit weird, but I'm going to go and just show you. So by default, and I'm going to go to a default patch again. When you go to the operator number 1, you need to know that all oscillators are going to be playing continuously. And this is something very common with any synthesizer. When you just remove or disable the envelope, the amp envelope, you can hear a constant sound, which is the oscillator just going and going, because this is by default what it does. So if I just lift the, the envelope, just going to go and kind of remove that all the way. I'm going to play sound, and notice it will never stop. Just going to go and keep ringing. Again, that's the way it works. All right. So if I go and play another one, it's going to play and just keep going. It will never stop. The thing is that, of course, the sound will start when I press a key. Notice that we get something when we press a key. So it means that the envelope is going to be re-triggered every time we press a key. And that's, how we can, of course, play different keys and get different notes. So the sound will end with an envelope, will start with an envelope, and then at one point it's going to end. So we get that cycle, but it starts when we hit a key. Okay. So then if I go to the operator number 2, I'm going to go up on the volume, and we know now the one is the carrier and the other one is the modulator. So we get that sound. So okay. So then of course we know that both are, when we hit a key, they're going to be starting pretty much at the same time, right? They start at the same time. So I'm going to go to the maybe the 1, and I'm going to select saw wave. Okay, so we get that sound, right? It's just pretty nasty. That's fine. So we all the oscillators by default, and I'm talking about all the oscillators, all the operators, they will restart whenever we hit a key. So we play a note, the envelope will start at one point, and we hear the sound, right? We hear that key, and they all will be in sync. The envelope is the same one, and it will start always the same for all the different keys. Now, notice that you get an oscillator sync. And this one, what it will do, it will kind of deactivate this sync between all the operators with the envelope. So they are not in sync anymore. And we're going to expand this much later when we talk about the full power of envelopes. But right now, when I do oscillator sync, I just turn it off. I'm going to get, every time I press a key, and if I press kind of rapidly, we're going to get a different sound every time. And we can really hear this. Notice it's just a little bit different. Every time I do it, it's just a little bit different. And if I turn it on, all the oscillators are going to be in sync. So it's always the same sound. And notice that it does sound different just a little bit. It's just a slight variation. There we go. You can really hear now. And if I go in sync, all the operators are in sync. So this is going to be very important when you use many oscillators and you're going to be unsyncing some of them, and then you're going to sync some other ones. So this is again important when you are using many operators and many modulators and carriers in this case. Again, this is what the oscillator sync. I know it was a long explanation, but I really needed to kind of a way of explaining what this does at the end of the day. So that's it. If you think about this, it's just pretty simple. At the end of the day, you have a carrier that you will, of course, pick a sound, pick a ratio right here, and maybe then select an envelope, and you're going to get a main sound. And then if you want to, you know, add a modulator, you're going to be adding a modulator and maybe add a different wave with a different pitch, and you're going to start to get different sounds. So the FM world, it's a lot of experimentation. You don't have you do have rules, of course, but you don't have like a book that it says, okay, this one, it sounds like this when you do this. You, of course, you can go and read and trying to find kind of a very specific examples of how creating a bell or how creating a lead or how creating that. But there's, again, a lot of experimentation because you have a million features that can radically change the sound when this one is modulating something else, or this one is modulating the 2 and the 2 is modulating the 1. And I'm going to show you right now. So since we understand how all of this works, you know, we really understand, I'm gonna go and build sound and just build something. I'm gonna go to the default template. I'm gonna start from the scratch. I'm gonna go right here, and we are gonna be on the operator number 1. And I'm not gonna go crazy. I'm gonna do something simple. So we are gonna be using this. We are gonna go and use a sine wave by default, and I'm gonna alter how the right here the envelope works. I'm just gonna make it a little bit shorter, just a little bit shorter. So if I do something like this, we get a dumb sound, right? And that's fine. Okay, so we get that sound. Now, of course, we are using this algorithm. So I'm going to say right now we get the number 1. So I want to get the number 3 as well. So I'm going to go up in volume on the number 3. So notice that there is a difference in sound because they now have different values, different envelopes. Now, what if I wanted to go and use the same thing for the operator number 1? So you can go manually and, you know, start adjusting all of this manually, or right here, you notice that you get the copy option. So you can click this, and then I'm going to go right here and say copy and paste to the number 3. So now the 3 and the 1 are completely the same, just completely the same. There's no difference. All right. So we know how this works. Now, of course, you cannot argue that this sound is just kind of a very dull. So I'm going to go to the operator number 2. I'm going to go up in volume, just like this. And I'm going to go and say, okay, so this is my main sound, not very pleasing. So what I'm going to do, just going to go and change the ratio. I'm going to go all the way up, and I'm going to select a 12 ratio, right? You're just kind of changing the pitch. And I'm going to go and change the envelope of this one. It's going to be much shorter than the other ones. I'm going to go there, just create a new point, and, you know, maybe doing something like this. And now I'm going to go copy this one, and I'm going to paste it on the number 4, because the 2 and the 4, the 2 and the 4 are modulators to the carriers, to the 1 and the 3 directly. So now, since we have pretty much the same, but we have a different ratio and a different envelope, but, you know, they're essentially the same, we get a bell. And if I go to effects and add something like, I don't know, something dumb for now, a delay, and then maybe, I don't know, a reverb, something dumb, we get a super cool. We get the bell, and this is a very classic sound for the DX7, just using sine waves. We are, again, not going crazy. But now notice how radically this changes when we change the envelope, right? The envelope is very important for a modulator. It will just change how it sounds, how the carrier sounds. And same thing for the right here for the ratio. If the ratio changes, it will change the sound radically. If I go all the way down on this one and all the way down, we're gonna get something very, very different. Again, it's just amazing, and it's mind-blowing the amount of sounds you can get out of this. Just, you know, changing the envelope and changing the ratio. I need just to end on a C note. So yeah, so this is a Femme Synthesis. Now, of course, we did something simple. Now, the problem with the Femme Synthesis is that you have 6 different operators. You can have different ratios, different waveforms. You can detune them. You can do different filterings, different envelopes to, you know, all the different operators. And you're always going to get something or crazy or something like a bell or something like a lead. So again, it's very complex because you have a lot of options. That's why a Femme Synthesis is kind of a hard, let's say. But, you know, I wouldn't say hard. It's just you get so much that you can do a million things and you end up sometimes getting confused. But if you always start simple, you know, go to the fundamental, which is going to be, let's say in this case, we are doing a bell. We know that when we do a bell, the sine wave is just, you know, the way to go. And then we just add a little bit of something extra, you know, just to get that bell going on. Or maybe I want to go to this one and just change it just a little bit. Notice that we get different, you know, different waveforms right here. Maybe I'm going to go to a triangle. I don't know. I just want to try. So I'm going to go copy in this one, paste it, and see how it sounds. Well, it sounds very, you know, similar in this case. Let's just go crazy. I'm going to go do a saw. Why not? I'm going to go and do a saw. I'm going to go copy, and I'm going to go and paste it. And now we're getting a much more dirty kind of a bell. And as much, you know, if you go crazy right here and you do a lot, you're going to start getting much more dirt. But remember, you always have a cutoff filter. And in the case of this one is the 1 and the 3. So I'm just going to do maybe a little bit of cutoff if the high frequencies are just killing us. So in this case, I'm going to just copy this one, go to the carrier, and notice how, you know, how different it sounded from the first one, you know, from just using the sine wave. So yeah, this is a Femme Synthesis. Welcome. It's just an amazing thing to have. Now, if I have to advise, if you really like this and you really like the plugin and you want to get more into a Femme Synthesis, in my opinion, the best synthesizer that you have today, you know, the market today, you can buy is the Op6, the Korg Op6. I have that thing, and it's just mind-blowing the amount of sounds you can get out of that thing. It's just amazing. Just check it out. It's the Korg Op6. Now, if you're not confused and you kind of get the idea and all the things you can do, congratulations. You just gained the knowledge of FM synthesis in this case with the DX7. It's okay. So we're going to go to the next one. We are done on this section because we still need to learn some other things we can do with this plugin. We're going to go to the part number 3 of this, series, and we're going to talk about the envelopes, everything we get right here, because now we know that the envelopes are super important for the sound. All right, so let's go to, the next video. I'm going to be uploading maybe one video every day of the series, or maybe one every 2 days, something like that. And okay, so, just see you on the next one.